Hello everybody, today we'll be talking about how to find the derivative of trig functions. Previously to this, I think we were talking about how to solve for the power rule using the derivative, and we also talked about the quotient rule and also the chain rule, so those will be required in order to do this part of the task. So today, as you can see from the page right here, we're going to learn how to take the derivative of these 6 trig functions that we learned from trigonometry from last year. So to begin with, let's look at the first one. Here we want to take the derivative of sine of x. And so what we're going to do is we're going to solve for this using the formal definition of limits. Now, we're not going to be doing this every single time. We're just going to be doing this for probably just the sine and the cosine function. And then from there, the other 4 will be actually fairly easy then. So to begin with, let's go ahead and start by saying that the derivative of sine of x is the following then. Limit as h approaches towards 0 of sine of x plus h minus sine of x all divided by h. At this point, you're going to need to use a trig identity in order for you to figure out what happens next. So the trig identity is basically looking at this part over here. And if you remember, the trig identity says the following. The sine of a plus b, that is going to be equal to the sine of a, cosine of b, and then plus the cosine of a multiplied by the sine of b. So making that as my direct substitution here, what we have now is going to be limit as h approaches towards 0, the sine of x multiplied by the cosine of h, and then plus the cosine of x multiplied by the sine of h, and then we also have the leftover part, which is the sine of x, all divided by h. Okay, so we will now go ahead and combine some of the like terms so that we can start seeing some of the stuff. What we'll do is we'll take a look at the first term right here and also the last term right here, where you'll note that they both have sine of x in common. So I'm going to go ahead and factor that out. So the next part, we are now going to have limit as h approaches towards 0. The first and third terms, factoring out the sine of x, okay? Then we have multiplied by the cosine of h minus 1 all divided by h then. Okay, so we're going to give this part its own denominator and also its factor, so that it'll be a little bit easier to look at. Whereas the second part over here, well, that's what's left over, so we're going to write that out also as well. So plus the limit as h approaches towards 0 of cosine of x multiplied by the sine of h over h. And you'll note that the way that I'm writing this right now, what we're doing is we're kind of like isolating the terms so you can see what is being affected by the limit and what is not being affected by the limit. In the first part, the sine of x is not affected by the limit at all, so we can go ahead and pull that out. And what's left now is the limit as h approaches towards 0 of cosine of h minus 1 all divided by h. And then plus the second part, the cosine of x is not affected by the limit because it's in terms of x, nothing in terms of h. So we can take that out as well. Limit as h approaches towards 0 of sine of h over h. Now, some of these, hopefully you guys are familiar with. If you remember this part right here, the limit as h approaches towards 0 of sine of h over h, that is just equal to 1. So we can actually make that direct substitution right there too. So next part, this will give us cosine of x, and then we have just 1 over here. Now this guy right here, you might not be familiar with it because you don't really see it that often. Well, just to kind of make it a little bit quick, the answer is supposed to be equal to 0. So you can either verify that by solving for it using a trig substitution via limits, or you can use a calculator. But nonetheless, I'm just going to go ahead and give that to you right now just so that we can save a little bit of time. So in the end, the derivative of sine of x, you'll notice that the sine and the 0 cancels out. So that's going to be just cosine of x then. So that's going to be my derivative of sine of x. Okay. And you might have, if you saw my previous videos, then back in chapter 2, we kind of saw this graphically too as to like why one is the derivative of the other. Okay, well, there you go. There's the derivation. So hopefully it wasn't too bad. Now, let's go ahead and do the same thing for the cosine equation, and then afterwards, we'll do the easier way. So this time, I want to take the derivative of cosine, and again, we're going to go ahead and start by taking the limit as h approaches towards 0, the formal definition of the derivative then. For this one, you'll notice the cosine of x plus h. So similar to the previous problem, what I'm going to need to do is use the trig identity. And the trig identity, just to kind of write that out so you can see it, it's the cosine of a plus b, that is supposed to be equal to cosine of a times the cosine of b minus the sine of a multiplied by the sine of b. Now, before I go on, I should also mention that for some of these right here, for all of these guys, when I'm doing the derivation, it would be actually good if you guys want to give it a shot just to see if you can get the same answer as me on your own, just to, get the practice in. Now that I've given you the trig substitution, try to plug it in and see if you can solve for it. What is the limit? And if you can, that would be great. So, pause it if you need to. But if not, we're just going to keep going on, okay? So let's go ahead and write it out. Let's see. Next, we're going to make that substitution for the limit. And limit as h approaches towards 0. So now we have cosine of x. Oops, not a. Let me go ahead and erase that and make it look a little bit prettier. So cosine of x multiplied by the cosine of h minus the sine of x multiplied by the sine of h, and then minus the cosine of x that was there to begin with, all divided by the h that's in the denominator. And thinking about what we did in the previous part, we're probably going to take the first and the third term and factor out what they have in common. The second term never have anything in common, so you can see why that's always never chosen in this case then. So limit as h approaches towards 0, okay? And again, remember, keep in mind this part right here and this part right here, we're going to factor out what they have in common. We're going to go ahead and take out the cosine of x that they have in common. Multiplied by what's left over is going to be the cosine of h minus 1, all divided by h. And then for the second part, now this one, be very careful. There is a negative sign over here. So that means this should be then a minus limit as h approaches towards 0. And then we have sine of x, which is going to be independent over there, multiplied by the sine of h divided by h. Okay. So as you can see, my setup is getting closer and closer to what we had earlier. This time around, it's the same idea still, right? We have this part where it's the sine of h over h, and as h approaches towards 0, that is going to be equal to 1. And for earlier, we said that this guy right here, when that goes to 0, that's going to go to 0 then as a result. So what we have left now is going to be cosine of x multiplied by 0, because that's where this is approaching towards, minus the sine of x multiplied by 1, because that's what it's approaching towards. So cleaning everything up, so this guy cancels out. So in the very end, the derivative of the cosine of x, that is just equal to the negative sine of x then. Okay, so those are the only two that we have to use the formal definition of derivative for. The other four, I promise you that's going to go a lot faster because you already know the product rule and the quotient rule. So let's go ahead and talk about these guys over here, okay? So derivative tangent. Now tangent, we don't have to use the formal definition of derivative because that's actually very gruesome and we want to try to avoid that if possible. But instead, maybe what we can do is look at this as the following. The derivative of tangent, that's the same thing as the sine over cosine. And what's nice about that is, hey, as soon as I write sine over cosine, that means that we have a fraction. So therefore, we can use the quotient rule because we have a function in the numerator and a function in the denominator. So if it helps you, just to kind of write it out on the side, we'll do it one time. If I have f divided by g and I want to take the derivative, it's supposed to be, again, recalling the quotient rule, is the bottom equation multiplied by the derivative of the top minus the top equation multiplied by the derivative of the bottom, all divided by the bottom square. So here I'm just going to go ahead and write those out. F, which is the top equation, is going to be the sine of x. And then g, the bottom equation, that is going to be cosine of x. And according to what we just solved for earlier, right, we can actually use those now. The derivative of f, which is going to be cosine of x, and the derivative of g, which is going to be a negative sine of x. And that now we can go ahead and use to our advantage to solving for what's the derivative of tangent then. So let's see, putting it all in, okay? According to my formula for the quotient rule, then it's going to be the derivative of g. So that is going to be cosine, it starts with g, so that means it's going to be the cosine of x multiplied by the derivative of f prime, the derivative f prime, which is going to be cosine of x also. Okay, so that's going to be cosine squared. And I think I jumped the gun over there with that extra square sign. So let me go ahead and erase that for you. Okay, so let me get rid of this guy right here. Okay, then we have supposedly a minus. Okay, and the next part is going to be f. So that is going to be the sine of x multiplied by the derivative of g. So that's going to be the negative sine of x. And all of that is going to be divided by g squared. So we're going to go ahead and put cosine squared of x on the bottom. And at this point, I really should mention that if you don't remember your trig identities, it's really good to brush up on it now because we're going to be seeing quite a that from here on out. Okay, the top part, we have the cosine squared of x, and then we have two negatives making a plus, and then that's going to be now sine squared of x, all divided by cosine squared of x. So that's where your identity is going to come in because the numerator, that's cosine squared divided plus sine squared, that's just equal to 1. All divided by cosine squared, and by my definition of the trig functions, this is the same thing as saying just the secant of x quantity squared. So that's your derivative of tangent, which is supposed to be secant squared. For secant right here, if I want to solve for the derivative, we can treat it exactly the same way. And yeah, we can go ahead and try to solve for it then. So let's see. Let's go ahead and write that out. So the derivative secant, if you remember, that is supposed to be the same thing as saying 1 over the cosine of x. Okay. And let's see. Well, let's go ahead and write it using the quotient rule. So again, the top function, the numerator, is just going to be plain old 1. The denominator, the function over there, is going to be cosine. We're going to take each respective derivative. So the derivative of 1 is going to be 0. The derivative of cosine is going to be negative sine. So let's go ahead and fill in everything. Okay. So here, let me just go ahead and write the quotient rule also on the side just in case. So it's supposed to be g f prime minus f g prime all divided by g squared. So the first part is going to be cosine of x, because that's going to be my function g, multiplied by f prime, which is going to be 0. And then we have minus f, which is going to be 1, and then multiplied by derivative of g, which is going to be negative sine of x. And all of that now is going to be divided by g squared, so that's going to be cosine squared of x. Okay. So let's see, numerator, we have the cosine and the 0, so that's canceled out. We have the negative and negative, that also cancels out, so that's going to be sine of x, and then all divided by cosine squared of x. And to make this into a form that's a little bit more applicable for future references, we're going to go ahead and write this as the following. Sine of x over the cosine of x, multiply 1 over cosine of x. And sine over cosine, that is going to be the same thing as tangent of x. Whereas cosine of x, 1 over cosine of x anyways, that is supposed to be equal to secant of x. So this would then be its derivative. Okay. Let's see. Keep on going. Let's go ahead and look at cosecant of x. So again, if you feel like you want to try this on your own, go ahead and pause the video and see if you can actually derive it, and we'll come up with and hopefully we'll come up with the same conclusion. So let's see, the derivative of the cosecant, that's 1 over the sine of x. So again, using the quotient rule, okay, so f is going to be 1, f prime would then be equal to 0, g is going to be sine, and g prime is going to be cosine of x. So by the quotient rule, then we have now the following. We have g, which is going to be sine of x, multiplied by 0, which is f prime, minus 1, which is supposed to be f, multiplied by derivative of g, which is going to be cosine. And then all of that is going to be divided by the g squared, so that's going to be sine squared. Okay, so cleaning up just like we did earlier, the sine times the 0, that's going to be 0. So that's going to be negative cosine of x divided by sine of x times sine of x. And again, I'm just writing it in this form so you can change it into a form that's a little bit more familiar or something that's more usable in the future. So let's see, cosine over sine, that is the same thing as cotangent. We have the negative that's out there, and 1 over sine, that is the same thing as cosecant. So then that means the derivative of cosecant is going to be negative cosecant cotangent. Okay. And finally, for the last one, I think I'm going to try to, well, might as well go ahead and finish it up, right? Because we have everything done so far already. So the derivative of cotangent, we're going to write this as cosine over sine this time. Okay. So the top function, f, that is going to be my cosine. The bottom function, which is sine, so that's going to be my g. So f prime, that is equal to negative sine of x. G prime, that is equal to cosine of x. So if I take the derivative according to my quotient rule, okay, let's see, that is going to be the sine of x multiplied by the derivative of f, so that's going to be negative sine of x. And then we have minus, we have cosine of x, that's going to be f, multiplied by g prime, that is going to be cosine of x as well. And all of that is now going to be divided by g squared, so that's going to be sine squared of x. Okay, so cleaning up a little bit more, I notice that we have negative sine squared of x, I have negative cosine squared of x, and all over sine squared of x. So the top part, if we factor out the -1, you're going to see the identity cosine squared plus sine squared, which is equal to 1. And then the bottom, we're just going to go ahead and keep the same thing. So because the top part is equal to 1, then that means we have -1 over sine squared of x. And then in conclusion, writing this in terms of the cofunction, that is going to be negative cosecant squared of x then. Okay. So here, let me just go ahead and finalize by putting everything up on the top so you can actually, put it all into conclusion. The derivative of sine, we said that's where we derived it, which is going to be cosine of x. The derivative of cosine is going to be negative sine of x. And then for tangent, it was supposed to be equal to secant squared of x. Cosecant's derivative is going to be negative cosecant x multiplied by cotangent of x. The derivative of secant is going to be secant of x multiplied by the tangent of x. And finally, the derivative of tangent, not tangent, but cotangent. And let me go ahead and get rid of that for you. Let's see, there's a small little trick I need to do for this one to erase actually. Let's see, and I think I was using purple for this one. So cotangent, the derivative of that is supposed to be negative cosecant squared of x. So the reason why I want to pull up this screen is so that you can see which, if there's a pattern that you can kind of see to help you guys to memorize this. For me, the easiest pattern that I'm seeing is that sine and cosine, they're always related to each other in terms of derivative. Tangent and secant, they're always related to each other in terms of derivative. And then finally, cosecant and cotangent, they are always related to each other in terms of derivative. So that's how I kind of like group them together to help me memorize this. Whatever it takes to help you memorize it, hey, by all means, all right? So let's go ahead and now take a look at a few examples of how to solve for some of these derivatives. So, and I'm going to, again, implement some of the product rule and the quotient rules that we've been doing so far. So here's the first example. We have the derivative of this product then as a result, and I want to find out its derivative. So just like what we did in the proof, the derivation, we're going to go ahead and pull out the two functions. We're going to go ahead and call the first one f. We're going to go ahead and call the second one g, right? And we're going to go ahead and write them out. So here's f, here's g, and we're going to solve for each derivative respectively. So f is going to be 2x plus 1. So the derivative is just going to be 2 using the power rule. G is going to be x minus the tangent of x. So its derivative is going to be 1 minus the derivative of tangent we just derived, which is supposed to be secant squared of x. Now, the first time that you've seen the trig derivative, you might want to put the list of all the 6 derivatives next to you, so then that way you can kind of go back and forth. But eventually, you're going to memorize it, and it's going to be a lot easier, okay? So this is a product, so that means we're going to use the product rule. So the product rule says it's going to be f times g prime plus g times f prime. So literally, that just means that you're going to cross multiply and then add them together. So the derivative of this is going to be the following. So let's see, it's 2x plus 1 multiplied by 1 minus the secant squared of x. And then we have plus 2 multiplied by x minus the tangent of x. So again, as I was saying earlier, so you can see that's f right here. Here's g prime, and then here is going to be f prime multiplied by g. So literally, like I said, just cross multiply and then add them together. Okay, let's look at a couple more examples, and then afterward, I think that should probably do it. Let's see. This time, we're going to take the derivative of e to the x divided by 1 minus cosine of x. So again, isolate which one's the first function. Isolate which one's the second function. So we'll call this one f right here. We'll call this one g right here. So f is supposed to be e to the x. So f prime, its derivative, is just the same thing, e to the x. Whereas g is going to be the bottom function. That is going to be 1 minus the cosine of x. And so g prime, its derivative, the derivative of 1 is equal to 0. And the derivative of cosine is supposed to be negative sine. So that means that you have negative sine of x. So that right here cleans up to be just plain old sine of x then. Okay. All right. So again, we said that this is going to be the quotient rule. So let's go ahead and write that out. So if you need to write on the side for yourself, that's totally fine too. So g f prime minus f g prime, all divided by g squared. Okay, so the derivative, let's see, g, that is going to be 1 minus the cosine of x, and then multiply by f prime, so that's e to the x. Then we have minus f, which is e to the x, multiplied by g prime, which is going to be the sine of x. And all of that is going to be divided by 1 minus the cosine of x quantity squared. And for something like this, I think it would definitely be nice to simplify this as much as possible. And the only thing I can see that you can do for simplifying is factor out the e to the x. And remember, simplifying means I want to keep it in factor form if possible then. So final answer would be e to the x times 1 minus the cosine of x, and then minus the sine of x, and all of that is divided by 1 minus the cosine of x quantity squared, and we'll go ahead and leave that as our answer then. Okay. All right, so here we have this one right here, and I think the last one, oh, that one's a tricky one, so maybe that one you can try on your own and see how it goes. Okay, let's see. So for this guy, I am going to use the quotient rule, which you can definitely see, and the one part that's going to be tricky is that it really looks like I need to use the quotient rule and also the product rule, because the bottom part is going to be sine of x times the cosine of x. But again, this is where I was saying earlier that, hey, if you remember your trig functions or trig identities, this is where it's going to be becoming useful. The trig identity to help me solve for this, actually, wait, I can't do that because I just realized that's going to use a different rule that we don't actually have yet. Okay, so we're going to have to kind of do it the hard way then, so as we said. Okay, so let's go ahead and try it out. F is equal to x squared plus the square root of x. And then we have g, which is going to be equal to the sine of x multiplied by the cosine of x. Okay. So f prime, its derivative, is going to be equal to 2x plus 1 over 2 root x using the power rule. And g, well, g, I'm going to have to take the derivative of that one using the product rule with inside. So this is where we were saying earlier that you have to use the quotient rule as an overall, as the outer function, and then we have to use the product rule for the inner function. So g prime, okay, here we go. So the derivative of this one is going to be, let's see if I can write this so you can kind of see it. Cosine of x multiplied by the derivative of sine of x, and then plus the derivative of cosine of x multiplied by the sine of x. Ooh, a little bit hard to see, so hopefully you guys can kind of bear with me for this one. Okay, so let's see. Cosine of x is just as is. The derivative of sine, that's going to be cosine. And then we have plus the derivative of cosine, that's supposed to be negative sine of x. And then we also have sine of x by itself. So putting it all together, we have cosine squared minus sine squared. And be very careful, that's not equal to 1. That's just as is. Or you can use the trig identity that's equal to cosine of 2x then. Okay, so you can use either one of those form will be okay. So let's go ahead and put it all together. Let's see. This is again using the quotient rule. So it's going to be the following: g f prime minus f g prime all over g squared. So the first part, g, that is going to be sine of x multiplied by the cosine of x. And then we have that multiplied by f prime, which is going to be 2x plus 1 over 2 root x. And then we have minus f, which is x squared plus square root of x. And then we have g prime, which we can use either one of those two forms. So I'll use the nicer, cleaner form. So that's going to be cosine of 2x then. And all of that is going to be divided by g squared. So then that means it's going to be sine of x multiplied by the cosine of x, quantity squared. And again, if you remember a while back, we said that if you are asked to solve for a derivative, you can actually just go ahead and leave it in this form for the most part. But if we're one of those people that like to look at a single fraction, then that's where you need to rationalize it by multiplying 2 root x to both top and bottom. But for me, for something like this, it would be okay then. Okay. All right, so there you go. So hopefully that'll help you out to learning the derivative of trig functions. I know I have one more example on the bottom, but we're just going to go ahead and leave that one alone because, again, I just made a mistake, and that's something that we can't solve for the time being. Okay, so take care, thank you, and I'll see you guys next time.